So first is we have to import NumPy as NP. Stop autocorrecting. And then we want to import matplotlib.pyplot as PLT. And so another thing is you don't have to have this as PLT. It would still import fine, but this is like a standard in the like computer science community to import NumPy as NP and matplotlib.pyplot as PLT, because that's what everyone does, and it's also easier to work with when you're trying to call different functions or use different aspects of these libraries, because of the notation that we have to use. So let's define our function. Let's say define plotting example, and we want to take two inputs, x and y. And so then it will, when you hit enter, it won't go all the way to the far left. It'll be indented. And so that means that this code is a part of the function. And so then you can just keep going. And then once you move over, it will not be a part of the function anymore. So let's say plot x, y, let's make them red circles, and let's label it experimental data. This is going to be a more of a general plotting function for various different data sets. So this will plot straight out our data and make it into the line, and that's it. The graph, it will be bare bones, so we can take a look. Let's say let's create our arrays. So I have already defined two arrays that I took data from one of my labs this semester. So the X values are absorbance of a chemical compound measured in, or the Y values are absorbance. I think I had that flipped actually. Oh no, that's right. Yeah. X is the absorbance, and then Y is the concentration of a protein solution. And so when light is passed through this solution, a machine registers how much light passes through and versus is absorbed. And there should be a linear relationship between the two, as defined by a chemistry equation that we don't really need to get into, but we are expecting the curve fit of this plot to be linear. So let's test that. Let's look first, plotting example, X array, Y array, and let's run it. Let's see what it happens. Oh, I might have to say plot that show. There we go. So it auto scaled it, and as we can see right now, it is already pretty linear, as we can tell. But let's add all the aspects of a good plot, like the axes, the legend, and let's also add our curve fit. So let's start with the curve fit. So let's define an array. Fit coefficients is equal to np.polyfit x, y, 1. So this, so we're taking the X array, the Y array, we're fitting them to with a linear fit. This is the degree of fit that you want. It can be 2, that'd be a quadratic fit, 3, and so on. But an important thing to note about this function, np.polyfit, so it will return an array of coefficients of the line of the polyfit, or of the curve fit line, the linear regression. So you have to use those coefficients to construct another array of actual values that Python can plot, and not just coefficients. So let's go to the next line. So we have to create like an X array of values for Python to plot with, because Python plots with an X array and a Y array. So we'll use linspace. And so let's look, our data goes from like 0 to 0.4. So I'll say 0 to 0.5, and then I'll include 50 increments. And so then to calculate, we use fit array equals, so to index into a so fit coefficients will return an array of 2 values, because a linear equation has 2 coefficients. If I made it a quadratic, there'd be 3 values. And this is important to know, because when you're indexing into this array, you have to specify the correct place, the correct index for the correct coefficient. So let's say fit coefficients 0. So this will be the first number in the array, and we want to multiply this. Where's my star? Multiply this by val. So it will take all the X values, multiply them by the X to the 1 coefficient, and then we need to add all of the X to the 0 terms. So that will be in the second, that'll be the second number of the array. And we don't need these parentheses necessarily. And so then that will be like the Y array to plot. And so then we have to add all, or we have to plot this first, actually. Let's say plt.plot val fit array. Let's make it a blue line, and let's label it linear regression. Okay, and so then next, let's add our title. So plot.title, a plot of X versus Y, let's say, and an X label, independent variable. So even though I'm using a specific data set to plot, this is just going to be our general plotting function that, so I'm making these general, even though I could specify absorbance, concentration. So that's just to clarify. So let's add our Y label, dependent variable. And then can't forget our units. So just to remind you that you need to make sure you have your units on there. So include a little units. And then let's add our legend. So location, let's put it in the lower right again, because it's going to be a linear. So up here is taken up. So you could do upper left or lower right would probably be 2 good ones. And then, so we specified location. Let's just put on the shadow. And then let's make font size equal, should we make it? Small, font size equals small. And let's take a look at this. So I stopped running that, and then let's run this. Oh, I have an error. Font size. Perfect. So because it shifted it a little bit because I specified my val array to go all the way to 0, and at 0 fit array had a value of -1 or somewhere around that. So it already rescaled the graphs perfectly. It added our line on top of our data so that we can see that this line is actually a very good fit of the data. We have our labels, our legend, and our title. Let me just show you what shadow false is really quickly. It's really not a big deal. You don't even need to include it, but it just looks like a normal thing. Yeah, so that's it for this. Um let's take a look. So I will send out the slides later, but hopefully you followed along and kind of were able to see how different functions work together and how you can specify different things to change the graph differently. And so here's the code that I worked off of, and it has comments. So you can use a hashtag, or what is that, a pound sign maybe. So you can use those to comment out your code. So anything with a hashtag in front of it won't be run. It's not treated as code. So this is another good step of good documentation of your code, so that if I just gave this to you guys, hopefully you'd be able to understand better with this code and have some reminders that I put in. So then let's go through some takeaways. So this was our graph that we created, and like I said, the data looked great, and the plot actually looks pretty good too. So depending on the degree of the curve fit, the array that, so going back to, oh shoot, I just deleted, I want to try to open a tab, I deleted it. So our fit coefficients, you have to be mindful again of the degree of your fit, and then how many coefficients will be in that term to create, in that array, to correctly create a y value array to plot. And depending on the range of your data, you will have to change val so that it fits pretty well. So if instead I said 0 to 5 instead of 0 to 0.5, this line, my graph would be so much longer, and it would be hard to see because the region of the experimental data would be so much smaller. You just need to reformat it for it to look nice. And then, yeah, you can personalize your graphs and utilize the powerful tools that Python provides.